Hello everybody and welcome to this session on Helix on-prem upgrades. My name is Mark Walters and I've been with BMC for more than 20 years now. For the last couple of years I've been a member of the SEAL team and I've been focusing on the on-premises Helix releases. As you may be aware, last week the latest versions of both Helix ITSM and the Helix platform were released. So this session hopefully is quite timely and we're going to have a fairly high level overview look at what's involved in doing the upgrade. We'll talk about the upgrade preparation, the steps that you need to do before you get started. We'll look at the different infrastructure updates that you might need, so Kubernetes, ingress, that type of thing. Briefly mention what we mean by zero downtime upgrades, because that's relevant for these products. Then we'll look at a little bit more detail at the Helix platform upgrade steps and the Helix IS or ITSM upgrades. So the first step is going to be the upgrade preparation. It really is key to a successful upgrade to make sure that you've reviewed the documentation, you've downloaded all the necessary material, all the artifacts, and that you've done everything you can to get yourself ready and set yourself up to have a straightforward upgrade. I somewhat jokingly say review the documentation, but it really is very important. There is a lot of it. It's complex. It's several different products that are being upgraded, so you need to read it carefully. But there's a lot of information in there. For example, the versions of the infrastructure that we support are changing, particularly with these new releases that have just come out. We've bumped up the Kubernetes and ingress versions that we support. We've also have an update to some of the client tools such as Helm that we use that you may need to refresh or upgrade on your deployment engine and installer machines before you get started if you have some of the older versions. We've introduced across the various versions different configuration settings. So for example, in the 21302 release of the Helix platform, we added a new load balancer that you needed to register in your DNS and possibly also in your certificates if you're not using wildcard certificates. So you need to bear that in mind if you need to get those refreshed from your CA before you get started. Some of the configuration parameters have been renamed. The deployment environment, for example, in earlier releases is now the deployment size. And we're going to be looking at upgrades from the Helix platform 22201 all the way up to 23202, the latest release. And there have been some significant changes there, particularly Postgres. We moved the Postgres release that we use from one based on Bitnami to one based on Patroni in 22.4, and then there were changes to the Helix Logging components in 21302 where we moved them out of their own namespace and actually in with the platform. You will also need to download and synchronize all the new container images for the different releases that you're going to be upgrading to. Have a look at the docs. There are pages that provide you with text files that contain the list of all the names of all the images, and some scripts that you can use to synchronize them. Or if you're using something like Harbor, for example, as your own on-premise registry, there are some replication rules that you can set up to help copy those across. You have a choice when doing a deployment. It is technically possible to actually pull the images directly from containers.bmc.com, our public DTR Docker trusted registry. However, I would recommend that that's really not the way to go. It's much better to set up your own registry on site and to synchronize those images from us to your local system. Really for a couple of reasons. The performance is likely to be much better. The size of these images is not insignificant. I think it's certainly tens of gigabytes in total that are used. So if you're having to pull all of those across the internet, across your internet connection, actually at the time you're doing the install, that may be a rate limiting factor. And the other thing is both availability and reliability. the images will need to be available once the deployment is complete. It's not a sort of a one-time job once you've downloaded them and used them for installation that you can delete them. It's possible that those images might be removed from your cluster as the system does disk maintenance. So if a pod is killed and needs to be recreated, it may need to go back and pull that image again. So you want to have them on your local registry. So definitely consider going the custom on-site registry, either using Harbor, which is the example that's used in our documentation, but any standard registry server, Artifactory, JFrog, whichever one it is that AKS, and for example, use all of those. We have customers using them successfully. One thing to note, actually, that just came up recently, the BMC communities, for those of you perhaps that use it in the containerization group, somebody noted that the image paths have changed. So up until this point, all of the container images have been containers.bmc.com /BMC, and then a project name, LPOOX, LPORY, denoting the different products. Starting with ITSM 22106, the LPOOX has been dropped from most of the ITSM or IS image names. So sort of don't be surprised if you see a mix of both those with and without. Very important step before you get started is to back up your databases. So for the Helix IS and Helix platform, the two different namespaces, we have different data stores. In the platform, the various data lake or data tier components store their data on persistent volumes, which is the block storage that you have attached to your cluster. We don't recommend a backup tool for these. That really will depend on your local preferences. There may be limiting factors based on the type of Kubernetes that you're using, whether it's, for example, Rancher based or OpenShift, or maybe you have an existing system that you already use. So for the Helix platform components, backup using whatever you have available. The Innovation Suite database is either a SQL, Postgres, or Oracle database that is external to your cluster, and I'd say chances are you again already have a backup solution in place, but it is always worth making sure that those backups have been taken and verified before you start an upgrade. As well as updating our products, we've updated some of the infrastructure components, the supported versions that we use. So now we have bumped up the Kubernetes and OpenShift support to more recent versions. It's worth noting actually with Kubernetes 1.25 that there has been a change to the way pod security is managed in the namespaces. So there's a little bit of extra care needed to be taken if you're using that release. If you're using the advanced security features, you probably should already know about it and be aware of what's necessary, but as it says here, you need to make sure you're using baseline pod security standards. The package manager Helm that we use was previously recommended to be version 3.2. We're now up to 3.11, and the Ingress Nginx controller that we're using is either 1.64 or 1.7, depending on the version of Kubernetes that you have in place. If you need to do, or if you're doing an infrastructure upgrade, again, going into details is more than we can do in this type of presentation, as it will vary very much depending on exactly what you're using. Is it vanilla Kubernetes? Is it one provided by Tanzu, for example, or EKS? You need to refer to the docs or talk to your local Kubernetes experts to find out how that can be done. Hopefully, and in most cases, it should be a largely transparent upgrade. If you have a cluster with enough resources, it's possible to do a rolling update whereby the master nodes are upgraded one at a time first, and then the worker nodes are drained, which means all of the pods are removed from them and distributed onto other nodes, and then that node can be updated and that process proceeds throughout the cluster, one node at a time, until the upgrade's completed. If you are doing an upgrade, it's one of the things you need to do actually before you start the Helix application upgrades. So zero downtime, what do we mean by that? For everything other than the compact deployment of the products, both the Helix platform and Helix IS, we have high availability, and by that it means that we have multiple instances, multiple pods for each of the services that are deployed. So it is possible to do a rolling upgrade of those applications, which I'll try and demonstrate in a moment using the graphics. One thing to note is that the minimum number of nodes is important. There are several services that are part of the Helix platform that have what are called pod anti-affinity rules, to make sure that the individual pods for that application are put onto different nodes, which will protect you, of course, against a node failure. If you ended up having two of your three application pods on the same node and there was a hardware issue, you maybe wouldn't have high availability. So you need to have at least four nodes for those types of service, so that they can be upgraded successfully. So what happens in this sort of rolling update that we have as part of the zero downtime, and this is done for both the platform and IS, it's just different in the way that it's managed, whether it's part of the Kubernetes system, the Kubernetes managed objects, or whether it's done manually by the installation scripts, where we scale up or scale down or start an extra pod before we shut down the new one. So what we have here is the cluster in its current state, running a particular version of the application. I just picked Redis as an example. We've got 4 nodes and we've got 3 replicas of the pods, and there's one running on each node because of the anti-affinity rules I mentioned earlier. So when an update is done, the first thing that happens is a new version, a pod of the new version is created. And because we have one node with no existing Redis pod on it, that's where it gets created. And once that's up and running, one of the pods on one of the other nodes is shut down and another one is started, and then that continues. We shut down one, start another one, which means that at all times, notice that we always have at least 3 pods running to maintain high availability. And then when all 3 of the new version pods are up, the final old version pod is shut down, and there you go, we are upgraded. And because of the high availability, all of that should happen without any impact to the application. So you're able to continue using the system while the update is done. Now we'll have a look at what's involved in actually upgrading the Helix platform itself. So new in version 23.202 is the configuration discovery utility. So for those of you that have done installations, you'll be aware that we have these config files, the infra config and the deployment config, where all of the different installation parameters, the customer specific information is set. And that includes things like the namespaces that you're using, the host names for the different services, storage classes, all that sort of instance or customer specific information is set in those files. Now, some customers maybe have had the system up and running for months. Maybe that initial installation directory where those files were created has been lost or overwritten. Maybe the system that ran the install was a virtual machine, and that virtual machine has been decommissioned. So it might not always be straightforward to recreate the infra config in particular, not so much the deployment config. The options are a little less complex in there, but particularly the infra.config file has a lot of parameters that you, unless you've made a note of them, you may not remember. We do have within the system a config map that has copies of both the infra and deployment config that were used at the time of installation. I don't think it's been documented anywhere up until this point, but it has always been there, and in this new 23.202 release, we've added a utility to be able to read the values from that config map and use them to update the new infraconfig.file before you get started. So it will take all your existing values, put them into the infraconfig, as well as updating it for you with your customer specific data. It will also list any parameters that have changed their names, as I mentioned earlier. The deployment environment changed to deployment size. It will also list anything that's been added as a new configuration parameter, and that will largely depend on the version that you're upgrading from. So version 22.201, for example, there'll be more changes if you're upgrading from that than if you're already on 23.102. You can see there where you'll find it. It's all fully documented in the online docs. I'm not going to go into details of exactly how to use it, but it's a simple shell script that runs. You give it the namespace of your existing Helix platform, where it's installed, and it'll go ahead and it'll print out some sample output there. It only takes a few seconds to run. You can see this was run against, I think it was a 22.201 system. So there are a bunch of new settings in the infraconfig that weren't relevant or weren't used in the version that's currently installed. And the error regarding the EFK Elasticsearch Kibana, that's harmless. That's just because that version that we're upgrading from didn't use that name. It used a different name for the Helix Logging deployment that's part of. So, or if you don't have Helix Logging installed, for example. But as you can see, the important note at the end: make sure that once this has been run, before you plow on and start doing your upgrades, you do go through and do a bit of a sanity check on what's been added to those files. If you're upgrading from Helix Platform 22.201, there's one big change that you need to be aware of, which was changed to the Postgres database that we use as part of the system. Up until that point, it's based on a release from a company called, or a community called Bitnami. We decided for various reasons to move to one based on Patroni. So before you actually go ahead and start your upgrade, there is a separate migration step. Again, using a script that's documented fully online. You need to edit the script before you use it. There are some passwords that need to be set, passwords that we use during your installation and can be found in various config files, and it's explained how you get those. And what this does is it runs a deployment to introduce or to create the new Patroni Postgres pods as parallel or in parallel to the existing Bitnami pods. So you have two instances of Postgres, one based on Bitnami that's currently in use by all of the applications, and a new one based on Patroni, which will be used by the upgraded versions. As well as actually deploying the pods, the script also does a data migration. So it copies all of the data from the existing system into the new database using the various Postgres, I think pgdump and pgrestore tools. So that's a sort of discrete, separate step. If you encounter any issues during the migration, you have plenty of opportunity. There's nothing committed at that point. You can, if necessary, you can even remove the Patroni deployment and rerun it after you've corrected whatever caused the problem. So it's a standalone step. Once the upgrade has been done and all of the pods have been migrated and are now using the new Patroni system, you can scale down and remove the older Bitnami pods to free up a little bit of resources, both PVC, storage, and also obviously memory and CPU. Helix Logging was another thing another component that has had a number of changes over the releases. In the 22.2 release, it was based on a fluentd daemon set, and all of the components ran or run in a Helix Logging namespace. 22.4, there was a small change from fluentd to FluentBit, but still the Helix logging namespace was used. In 21.302, and we moved the components into the Helix platform namespace. So the Helix logging namespace was no longer used. In 23.202, so the new release, there's been a fairly significant change. So there is still the option to enable and install the Helix logging, but you don't get the full EFK, Elasticsearch, FluentBit, and Kibana. It's only Elasticsearch and Kibana that are installed, and they are provided for compatibility with the Helix ITSM, which has an option to send some critical log entries from various log files on the IS pods into the Elasticsearch. As part of securing and making the system more robust, we found that the FluentBit implementation that we had didn't really provide as much value as we hoped. So it's temporarily been removed from the product, and we'll be back here, or we expect it to be back in future versions. There's a cleanup script that you can use to tidy up the separate Helix logging namespace instances. One thing that you may or may not want to do is to export the data that's currently in the system. If you've been using Kibana to look at the log entries, I think there's probably only a week's worth of data being stored. It should be being rotated and maintained and pruned so that it doesn't use up too much disk space. But if you do want to retain what data was there, you can optionally export it, and there are some steps in the online docs that explain how to do that using Kibana. You can use the script to remove the logging, and then I say it's optional when you come to actually do the upgrade as to whether the Elasticsearch and Kibana are deployed for use by IS. The Helix platform upgrade itself is fairly straightforward. You run the configuration discovery tool and update your configs, review those files once they've been modified to make sure that, for example, any missing parameters, new parameters have been added. Make sure that they are still relevant. So it's possible if, for example, you change the configuration of the system after the original deployment. Maybe you've manually gone in and edited something. You've changed the name of a mail server, perhaps, or think of another example. Maybe you changed the number of replicas. Something that was done outside of the deployment manager script that would obviously not have been captured in the config map. So make sure that they are all of the settings are still correct. If you're not using ITSM Insights, if you haven't selected that option in the deployment config, the deployment sizings have changed. So we up until version 23.102, we had small, medium, large, and compact. We've added two additional settings, two additional sizings, ITSM compact and ITSM small, which are for use for those customers that aren't deploying Insights. Once all of that's set up and ready to go, you run the Helix OnPrem deployment manager script, runs in upgrade mode, and as I sort of tried to show earlier with the rolling update, it will go through and for each of the components, Postgres, Redis, Victoria Metrics, RSSO, all of those different services. The new pods are introduced one at a time, and the older pods are retired or deleted, and then that's it. You end up with an upgraded system. You can monitor the progress in several ways. There is the terminal window output of the actual upgrade script itself. The same information with perhaps a little bit more detail also goes to the deployment log. You could open another terminal window and actually tail that to see what was going on. And the other thing to be aware of and worth keeping an eye on is to actually watch the progress of the pods in the namespace. So have a look, run kubectl, get pods, use the watch option if you want to, and what you should see is that as the upgrade proceeds, you'll see different pods being created and deleted. The reason I say it's worth doing that is because the the deployment manager script, it does a lot of work parsing the configuration data that you've provided and using that information to populate configuration files for Helm charts and other deployment scripts. But once that's done and the deployment is actually sent to the cluster, there's a Helm command issued, for example, to send a deployment. The deployment manager script effectively goes into a waiting state and waits for the Helm deployment to complete. So if there is an issue on the cluster side, so perhaps a resource limit is reached, an image pull error, maybe there was an image that was missed and wasn't synced to your local repository, storage issue, anything along those lines that prevents a container, prevents a pod from being created and being used, the deployment manager script will just sit there and wait for the 20-minute timeout before it reports the problem. So if you're watching what's going on in the namespace, for example, in the case of the missing image, you would have time to go and synchronize that image from BMC, get it into your local repository, and the upgrade should continue without any problem once it's present. So you do have I think it's a 20 minutes by default is the timeout. So it is worth checking to make sure that nothing has gone astray behind the scenes. Once you've got your Helix platform upgraded, the next step is to move on and do the Helix IS. This, of course, is based on Jenkins rather than the shell script, the deployment manager that's used for the Helix platform. So this is the assumption being made here is that you already have Jenkins up and running from your previous install. You have all your pipelines set up and configured that did the installation. You may even have done an update. Perhaps you started off with version 21.305 and you added the update pipelines and upgraded to 21.306. The upgrade to 22.106 is slightly different, but follows pretty much the same process. First thing to do is to get the updated Git repositories. So all of the installation scripts and the Helm charts and the other deployment artifacts that are used are shipped in Git repositories. Git's a version control software, and it gives BMC a very handy way of maintaining consistency amongst the large number of scripts and configuration files that we use for the deployment. So the first thing that you would do is back up and remove the existing repository files that you have on your deployment engine, and they're typically going to be in a subdirectory of the home. I'm assuming you've used Git as the user. You'll have a home Git directory, and you'll probably have a repos directory under there in which these different repository directories are stored. At least that's, I think, the default for the setup script that we use now for the deployment engine. So the first thing I say is to back up and get rid of these existing directories, and then you unpack the installer file that you downloaded from EPD, and that will recreate them, but with obviously, of course, the new 22.106 versions of the files. So that's the preparation that needs doing at the command line, if you like. The next step is to actually go into Jenkins and create upgrade pipelines. Now, if you started with 21.306 and used the Perl script to do the preparation and setup of the deployment engine, you may not have created the pipelines manually. Earlier versions was a much more hands-on process where you actually went into Jenkins, added a new pipeline one at a time, had to specify the script path and the repository path. That was automated to a large extent in the last release. So again, fully documented online. Go into Jenkins, add a new pipeline name, make sure it matches what's given in the documentation. It does matter. Give the repository URL, which is an SSH link to where the files were unpacked on your deployment engine. Set the script name at the bottom there. You can see the Jenkins file. and create the pipeline. You'll almost certainly have to do that. Well, you will have to do that for the Helix full stack upgrade pipeline, because that is new in this release. You may have a smart reporting upgrade pipeline from earlier versions, depending on what you previously had installed. And of course, smart reporting is now being replaced by dashboards, so it's possible not many people will need that option. Once the pipeline's configured, the next thing to do is what's known as a dry run on the pipeline. So when you actually set it up, all you're giving is a pointer to where the pipeline definition, the script, lives. To actually get that script ready for use, you need to do what's called a dry run. When you do that, you select the pipeline. You can see on the right-hand side in the picture there, the Helix full stack upgrade pipeline is in a build now state, and that's the clue or the hint that the dry run hasn't been done. When you select that option, Jenkins uses those Git repository files that you downloaded and unpacked, and it gets the latest version of the script from those Git repositories and updates the pipeline definition. So that build now, the pipeline build will fail the dry run, and that's expected, but you can tell that it's done its job by looking at this menu again, and you'll see it should switch from a build now to a build with parameters option. If it doesn't, go back and double check that you've got the path to the repository correct, and the script file name, and there are a couple of other options that are possibly also worth checking, but it should switch to build with parameters. Several of the other pipelines are also updated. So the main, sometimes called the Uber pipeline, the Helix OnPrem deployment pipeline, each release adds and changes some of the parameters that are part of that pipeline. So again, there's a documented process that you go through to do the dry run on that. It will already be in a build with parameters state, but by rebuilding it, Jenkins will recognize the fact that the pipeline has been updated, and some of the parameters, the new ones that have been introduced, will be missing. So the build will fail, but when you go in and have a look at the pipeline definition again, you'll see that some of the parameters have been removed, some new ones been added, and you know then that it's ready for further use. And that's both the Helix OnPrem deployment and the Helix Generate Config pipeline that will need to be done for that. Then we actually come to do and run the upgrade. So in this case, select the latest run of the Helix OnPrem deployment pipeline. You can see there in the build history, it's the top one. Right click or click on the menu drop down, or even go into the pipeline build itself and then select the rebuild link from the menu. Then you can go through and review all of the parameters. Everything that you used in the previous build should have been carried over, with the exception of the CA certs file. Remember, every time you rebuild the pipeline, you need to reattach your CA certs file if you're using custom certificates. Set the appropriate options. The deployment mode becomes upgrade. Make sure that you select the Helix full stack upgrade option. The other parameters you need to verify. There are some new ones added around. I think that we are now encryption for the connection to postgres databases. All of the different repo pipelines, that's been consolidated. Rather than having a separate entry for each one, there's now just one pointer to the higher level repo directory, which simplifies things a little bit. So go through, make sure everything is set, and kick off the upgrade. And again, you monitor the progress through the console output of the individual pipelines. Remember, the Helix OnPrem deployment pipeline is the master pipeline that calls all of the other ones that are needed in order. So you'll need to make sure which is the currently active pipeline if you want to go and have a look at the console output. And again, monitor the pod status in the namespace. The same caveats or the same comments that I made regarding the possibility of failures for pods to be created due to missing images or other Kubernetes level problems apply here. Most of the stages that are run by the pipeline have timeouts. And again, once the information has been sent to the cluster, Jenkins is going to be in a waiting state until that completes or the timeout exceeds. So hopefully you'll be able to spot a problem, and again you have a window there where you can correct it and let the pipeline resume rather than having to start over. Just a quick comment about the time taken. So there is plenty of variability depending on the options that you select and the power and the speed and the resources available on your system. But typically a Helix platform deployment, fresh install, is around about 45 minutes to an hour, maybe an hour and a quarter. So around about an hour, give or take 15 minutes. And full install of Helix IS, including all of the options, is between maybe 3 and 4 hours. Each of the pipelines takes 35 to 45 minutes. Don't be surprised if the upgrades take quite a bit longer, because of the process of replacing all of the pods that are already running one at a time, and the double checking and the validation that goes on between it. Between the various stages, plus some of the additional upgrade steps that are needed. It's been I think in one of the ones that I did, one of the upgrades that I tested, it took twice as long as the original deployments. So it may not be the case with the current versions, and I say there is a variation depending on the options that you've selected and the type of system that you're running on. But don't be surprised if it does take longer than the original installations did. Right, thank you very much, everybody. One more step. After you've completed the upgrade pipeline, the Helix OnPrem deployment manager has run, and Helix OnPrem deployment pipeline has run and has gone through the full stack upgrade section. There is a new step that's needed on the IS side only, and that is an application pod restart. So there's a separate pipeline to do that. You rebuild the Helix OnPrem deployment that's just completed, unselect everything except the Helix restart, and click rebuild, and that will go through and do a rolling restart of all of the pods to make sure everything is synced and up to date. Right, thank you very much. I hope you found that useful. We have time for some Q&A, please.